Hello everyone, this video is regarding the distance formula and how the formula is actually originated. For me, it's a lot easier to memorize the formula when I understand why it works, rather than just not knowing how it works and memorizing a bunch of random numbers. So here's how the formula goes. D equals whole root of x1 minus x2 squared plus y1 minus y2 squared. Now you might be wondering why this formula works. So let's assume we have a coordinate plane with a x-axis and a y-axis. Now I have a horizontal line segment here. How do I know what the distance is between these 2 points? Well, that distance is just going to be the length of this line segment. So to approach this, I can label these 2 points as x1, comma y and x2, comma y. We just leave y as y because the y value is going to be the same. And that's why we don't have to differentiate between them. Because, well, I don't have to say this is y1, this is y2, because, well, they're the same number. What we're interested in is x1 and x2. So we know that the length of this horizontal line segment, or the distance between these 2 points, is just the absolute value of x1 minus x2, the difference between the x values of these 2 points. For example, if these coordinates were the first point being 1 comma 1 and the second point being 3 comma 1, we can plug this into our handy dandy formula and we get the absolute value of 1 minus 3. And then from there, we can simplify 1 minus 3 is negative 2. And the absolute value of negative 2 is 2. So our length is 2 units. And if we count on the coordinate plane, we can see that it's exactly 2 units. Now, what if I have a vertical line segment? How do I find the distance or the length of this line segment? Well, it's the same procedure. I can label these as x comma y1 and x comma y2. Again, the differentiating the x value doesn't really make much of a difference because they're the exact same number. We're just interested in the y values. So the length of this line segment is going to be the absolute value of the y values of these points. So it's going to be the absolute value of y1 minus y2. Now, an important thing to note here is that since they're in absolute value brackets, it doesn't matter which way we subtract them. We can do y2 minus y1 or y1 minus y2. Since it's an absolute value, we know that distance cannot be negative, so that's why we put the absolute value sign. And that way, we get our length as just being the absolute value of y1 minus y2. Now, for example, if these coordinates were 1 comma 1 and 1 comma 4, we can see that the x coordinates are the same. We're just interested in the y values. So we can plug this in and say the absolute value of 1 minus 4. 1 minus 4 is negative 3, so the absolute value of negative 3 is just 3. So our length is 3 units, and if you count, it's exactly 3 units. So we said that the length of a vertical segment was the absolute value of y1 minus y2, and the length of a horizontal segment is just the absolute value of x1 minus x2. Now I'm going to put those formulas right there. Now I have a question. How do we find the length or the distance between these 2 points? It's kind of tricky, isn't it? Because, well, we don't know how to find them. We can't really rely on those 2 formulas because this is a diagonal line and not a horizontal or vertical. But notice a really cool thing here. If I zoom in, we can see that we can form a right angled triangle with the endpoints of this segment. And this is going to be true for any diagonal line segment. We can always make a right triangle out of these. So now we know what the length of the horizontal line segment is, and we know the length of the vertical line segment. So we can say that the length of this bottom segment is just going to be the absolute value of x1 minus x2. And we can say that the vertical line segment is just y1 minus y2. Now, here's where the fun part comes. Let's say we know that with the Pythagorean theorem that um, the hypotenuse of a right triangle is equal to the sum of the squares of the bases. So a squared plus b squared equals c squared. Now, what if we apply this same logic to our line segment and find the distance of the hypotenuse, or find the length of the hypotenuse? Well, let's label these a, b, and c. And if I plug this into our formula here, we get the absolute value of x1 minus x2 every whole square plus the absolute value of y1 minus y2 whole square equals c squared. Now, since they're absolute value and we're squaring that number, we don't have to have the absolute value sign because a negative number, remember, if the distance comes out to be negative, we're still squaring it, which means it's always going to be a positive number. Hence, we don't need the absolute value sign. So we can just say x1 minus x2 square plus y1 minus y2 square equals c square. But we don't want c square, we would just want c. So we take the inverse of squaring, which is square rooting. So we get that, yes, so we take the square root of both sides, and we get that the square root of x1 minus x2 squared plus y1 minus y2 squared equals c, which is exactly the distance of our line segment that we wanted to calculate the length of. And you can notice that this is exactly the distance formula. And that's where this formula originates from. We're just using the Pythagorean theorem to find the sum of the bases squared and applying that to the hypotenuse or the diagonal distance we're trying to find. And yeah, so I found it really cool that this formula comes from the Pythagoras theorem. And yeah, that's how you derive the distance formula.